Hi, welcome back. So we are at the last outline of this section to discuss a practical case study. So imagine you have this zip file that contains a text. What we want to do, we want to make a search for a single word, for example, just for practical example. And then we want to perform a kind of a replacement between the word that we search for and change with a new word. And finally, I want to zip back the file as it was. Now, if I want to put all this line of a flowchart that you have seen on the screen, I could just categorize this going to be in 3 different steps: to unzip the action, to perform the find and the replace, and finally to zip the new file one more time. Why I have done that? To give you an intuitional idea. When I am doing my analysis and then design before I go and start coding, I should put this kind of a flowchart in my mind as a starting point. Now, the section of drawing the UML, deciding the objects, deciding the class that we have learned so far, I will leave it for you. I'm going to move directly to the final product and I will walk you through the idea from this particular perspective. So I'm back here to my Visual Studio Code, and the code has been written here. And you can see it's very tidy, simple, and actually a practical way. Now here I have relied on some external modules that you can check their documentation for further. One of them called the shut utility, and you have the zip file module. And then we have the path library, and importing the path class in particular. Now here's my idea. Let me show you what that would look like in real time. Now inside here, I have a text. Imagine I'm going to look for this word called search, and I want to replace it with other word. But it's not happening directly on the text, but it happens on a compressed file. So I'm going to compress this, and I will keep it as it is, mytext.zip. Now I'm heading to the command line. I will go and run, say, which word you want to change. One more time, and show you the word we want to change is this word, search. So I'm going to write in my prompt here, search. He's asking me a new word you want to add. Let's say Python. Task is accomplished. How can I guarantee that? If I hit back again and I open my zip file one more time, I open the text inside, you can see now the word changed from search to Python. Essentially, I have created here a main class called zip replace with its dunder. Whenever you want to instantiate an object from this class, there are 3 important, let me say, arguments you have to provide: a file name, the word you want to search for, and what is the word you want to replace or the new one. And each one of them, like the file name, is assigned to a local variable called file, and search to the search, and replace to the replace. You can see both of the search and replace. I put them as a private, whereby the file was just still open public. Then I have another variable called self.temporary directory. Here I am using the path class from the path library module. And what basically this self or temporary directory is going to do is going to extract where is the path of the file that you have just wanted to provide to us, or the file name you want to do. I have created here a mechanism as an interface. So basically, I just want the user, once instantiate a zip replace class from there, an object, provide these 3. Now the object is instantiated. I want to make the object access to only one particular method and just execute everything behind. So I make a kind of a public method called zip find replace. So this is just a method like an integral interface, so to speak. If the object instantiate and call zip find replace, what will happen? The zip find replace will go in this order. Call each one of these. Remember, as I said, unzip, make the action of replacement, zip again. It's exactly what happened. So in the action of unzip, what basically is going to be, he's going to call the self-temporary directory based on the file name that have been passed and make a new directory there. And then he's using with keyword, which is, you should be familiar with that, is going to be actually an action of opening and closing afterward. So he is calling this module zip file, which has a function called zip file, request you to pass a name of that file. And then I'm just an attribute out of that. Now zip will represent this particular new file. Then I'm using the function of extract all. So this happens concealed within this particular module. I don't have to worry how that happens. And after that, I'm using the exact documentation as requested by using a string and passing the self directory of that particular folder. Now the unzipping occurred in this temporary kind of a folder. After finish, I will make the action of find and replace. Now find and replace, what it does, it loop inside the temporary directory that is being created if inside this particular line. So remember this self.temporary directory that created from the unzipping. So this is the very temporary directory. It will be deleted afterward. So I'm looping inside the files which are inside. I am opening them as a file and I'm reading their content. After I'm reading the content and assign them to a variable, and I'm using a replace function for the contents because this is a built-in. In the replace, what I'm saying, I want you to go take the search string with the replace string. So replace will make sure to make the shift afterward. After you finish, I'm opening and I'm making the final change using the writing. Mission is accomplished. Final is to zip back the file. So here again, I'm using the zip file module, opening the file name in a write mode, and then I assign that as a file. Now I'm looping inside again this temporary directory, and I'm making sure file.write the file name with the new file name that is stored. After I finished, I'm calling the shuttle to remove the actual temporary directory. So this is just to remove the temporary directory. If you remember to make sure this will be executed, if the name is main, mean execute from here, this will be executed. So this can be more usable if I want to use this one from other kind of modules or import the exact modules as it is. If you remember, I'm just reminding you some of the information. So here I'm assigning static word, taking an argument from the user, which word you want to change, putting inside this variable, which word you want to add a new, putting inside this variable. Finally, I'm creating now the object or instantiating the object from the zip replace. Here I'm providing the file name, which we already saw, file name.zip. I can make this one automation. I can make it options if it's a GUI, etc. But I just put it this in a static way. I'm just using the change word and the new word. Finally, I'm just calling the function that's going to run these three. That's exactly what happened and how we got one result. I make some changes here. Let us assume in some cases, the user provide me with some word, and I wanted to make sure to actually generalize this capital letter and small letter issue. Sometimes imagine the text have the first letter is capitalized and not capitalized. It's a sensitivity there. Shall I make the match okay or not? So in this case, what we do usually make sure that whatever word you provide is going to be all converted into a little letter, so to avoid or removing some unneeded string, etc. So there's some action I want to make on this change word before I am passing it down here. So when I set this change word to the search string or to the replace string, I want to make some manipulation on it. And this is the best, one of the best scenario to use a property beside the one we learned previously as a cached value. So I rewrite this exact code the same, but I'm using now a property idea. So everything remained the same, nothing changed. But what happened when you instantiate the actual object from zip replace, you just need to provide me with a file name, nothing else. You can see now this search string and replace string they got with non-value. So there are nothing there. And then here I'm creating two properties. One property I call it set the search word. One property I call it set the replace word. And you can remember from the context that both of them will be setting one for this value and one of course will be for this value. Then I'm using the setter for both. And If you remember, just I will take the string and I will assign it to this particular value. So this here in this particular setter, I can do a lot of things with this search string. I can convert it, I can manipulate it, I can clean it, whatever. That's why property can be a very good example here. In the execution side, as you can see here, instead of using here this line, what happened? I encountered to take the word from as a prompt, to take the word you want to change the new word, and then I'm instantiating the object. I'm just providing the file name. So what happened now, after I instantiate the object, I took this one and I said whatever change word and I said whatever new word. Everything remained exactly the same, but the only difference, these two values now, it can be manipulated before instead of taking them as they are. This is a very good practical example. It can show you the use of property in action as well. So that was all about section number 5. Now we are at data structure perspective by object oriented. I will see you then.